Welcome to another video from explainingcomputers.com. Earlier this year I made a video about SSD life expectancy, which proved surprisingly popular. And since that time lots of you have asked me to make a video about hard drive life expectancy, and so here I am with this video. Now, the problem I have is that hard drive life expectancy is a much more difficult issue to talk about than SSD life expectancy, because SSDs basically fail for one reason. They fail when their flash memory cells can no longer endure any more program erase, any more write cycles. Whereas hard drives fail for lots of different reasons. So what I'm actually going to talk about in this video is all the different reasons that a hard drive can fail, and then I'm going to talk about what we can do to try and prevent that failure for as long as possible, and finally I'll draw some more generic conclusions. So here we have a 3.5-inch hard drive and next to it a 2.5-inch hard drive. And when you get a new hard drive or you buy a new PC with a new hard drive in it, the most likely cause of failure is a manufacturing defect, or else damage to the drive that occurred when it was still in the factory or at the retailer or in shipping. And what this means in practice is that when you get a new hard drive, it's got a small chance of having failure baked into it, and it's going to die in the first few days or weeks or months of use, particularly those first few days or weeks. And there's nothing you can do about that other than getting your money back and getting a new drive. However, what this does mean is it's a good idea to thoroughly test a new drive before you invest time using it, before you install lots of applications on your drive or copy lots of data to your drive. And you can perform a basic check for errors on a drive in Windows. But at least with a new Western Digital drive, what I personally do is to use a free program called Western Digital Data Lifeguard. And this offers either a quick or an extended test. And I always opt for the latter test, the extended test, which takes several hours to run depending on the size of the drive, but it does provide you at least some reassurance that the drive is free from defects when you've first got it. Assuming that a hard drive does not suffer an early death, it still remains a piece of precision engineering that will eventually fail. And to see why, we just need to take a look inside a drive. So here I've got a very old drive that I've broken into so we can take the top off and we can identify the 5 possible types of hard drive failure. Now, I'm sure the first thing you notice when we look inside the drive is this. This is the platter, this is the actual disk. This is why we call these sometimes hard disks. And some hard drives will have one platter, some will have multiple platters stacked on top of each other. But however they're done, the platters will have a magnetic coating that's used to store the data. And this magnetic coating can break down, for example if the drive gets too hot, and when it breaks down you can't store data on it, you're going to get what's called a bad sector on the drive. This said, all hard drives are clever enough in their electronics to actually cope with some bad sectors. Now, the next thing you'll probably notice looking at this drive is this thing. This is the actuator arm with on the end of it, it's got the drive head. And this moves across the surface of the drive like that. If I move it manually, don't do this of course with the drive unless it's broken. Don't open your drive up unless it's broken. And normally the drive head will float just above the surface of the spinning platter. But if you thump your drive, if your computer gets a knock or a kick or something like that, you can get a collision between the head and the platter, what's called a head crash. And this can damage the magnetic coating on the platter, and it can probably also damage the head as well if it's really serious, and that will result in the catastrophic failure of your drive. Another thing that can happen between the head and the platter is what is called static friction or stiction. So this is not where you get a collision between the two, it's where they get attracted together. Why do they get attracted? It's because they're very smooth surfaces. Obviously the surface of the platter is very, very smooth, the surface of the head is smooth as well. And if you get, for example, water vapour or another liquid, maybe the lubricating oil found inside the drive, if they actually condense on the surface of the platter, they will cause these two things to be attracted together and to stick. Or it could be you get electrostatic forces causing these two to stick, and that again will give you drive problems. Another reason a hard drive can fail is if you'd like the obvious physical one. These platters spin round, which means there's got to be a motor under here and it's got to have bearings and things like that. And there's got to be a servo here to move the actuator arm to move the head around. And this servo or the motor under here can both fail. They are mechanical components that will eventually go, and if they go, then you're going to have failure of the drive. And finally, the last reason a hard drive can fail, if we turn this thing over, you'll see on the back it has got a circuit board. It's an electronic device after all. And the circuit board can fail. It can fail if it gets too hot, electronic components don't like heat, and it can fail if it gets a voltage surge or voltage spike. So if you've got a faulty power supply in your computer, the circuit board will fail, or if you get a sort of spike or surge from the main supply, it can damage the circuit board, destroy the drive. So, in summary, we've got here our 5 reasons a hard drive can fail. We can get a platter magnetic coating failure, we can get a head crash, we can get stiction between the head and the platter, we can get spindle, motor or drive head servo failure, and we can get circuit board failure. And unfortunately, in time, one of these will kill all hard drives. Just like this drive, all drives will eventually fail. But of course, we want that to happen as far into the future as possible, so now I'm going to look at what you can do to preserve the life of your hard drive. In 2004, a hard drive monitoring system called SMART was introduced. This is now standard on all hard drives and indeed on all SSDs, and it stands for Self-Monitoring Analysis and Reporting Technology. And what it does is it tracks the activity and the performance of a drive in order to try and predict its imminent failure. Many utilities can now read a drive's smart data, such as the Western Digital Data Lifeguard application I showed you earlier, and as you can see, this reports the drive's smart status. And if this doesn't say pass, you should plan on replacing the drive very soon, or at the very least, back up all the data on the drive. You can also, in Western Digital Data Lifeguard, click on the drive and you can see the full spectrum of data on which the reported smart status is based. Other utilities that can be used to check the smart status of a drive include Crystal Disk Info, HD Tune and Hard Disk Sentinel, and I'll give you links to all of these in the video description. And I would very much recommend you run one of these utilities from time to time, every few months, just to check on the smart status of your drive. The most obvious ways to avoid a hard drive head crash are to make sure that you never drop your drive or drop your computer, and that you avoid shaking, vibration and sharp impacts, particularly when the drive is spinning. Laptop users need to be particularly careful, and my personal advice is to never run a laptop that's got a hard drive inside it unless it's sitting on a solid surface. In a desktop PC, the hard drive is obviously inside a machine that should be fairly safe, but you can still actually make sure you haven't got vibration problems by fitting anti-vibration mounts. You can see on this particular drive taken out of a desktop PC, it's got these little sort of rubber things on the sides. These screw into the drive and then that screws in turn into the case. Now these sort of mounts have to be designed for particular cases because they make things non-standard sizes, but then if you actually hit your PC, the drive itself is protected from the worst of the vibration, the worst of the impact. That can work in a desktop PC, but for external drives you might also want to use rubber mounts or rubber feet on them, and some external drives have got very good rubber feet, not all of them though. This is a drive you might remember I put together in a video a few videos back. This is a StarTech case with a 2 terabyte 2.5 inch drive inside it, and I fitted this with my own rubber feet. You can see on the bottom there quite a deep rubber feet, very squidgy rubber feet, so that when this drive is on my desk being used, it's absolutely protected from vibration, or as much as it possibly can be. And because I want to keep this drive safe, not just from a potential head crash, but other things, I actually keep this drive when not in use in one of these things. This is a penny case. This is a case you can use to keep all sorts of things in, which is actually anti-shock. It's fully waterproof. It's even got a seal to be hermetically sealed with a release valve for any pressure. And so I keep this drive when it's not connected, and I would remind you not to have your external drives connected all the time. We've seen ransomware attacks recently and make that very clear. External drives constantly connected are not a defense against things like ransomware, so you must have some drives non-protected. Anyway, I keep this in this case, and I also put something like this in. This is a bit of silica gel, which will take out any moisture to prevent any stiction problems. So that's how I keep at least some of my drives absolutely secure, as secure as I can be, to try and prevent failure when they're not in the computer. If a hard drive gets too hot, it will significantly increase the chances of platter magnetic coating failure, stiction, circuit board failure, and possibly also spindle motor or head servo failure. It's therefore a good idea to know how warm your hard drive is running and to do something about it if it's getting too hot. Fortunately, temperature sensors are included in all modern hard drives and can be read by many utilities. Personally, I tend to keep track of my PC's health status using something called Open Hardware Monitor. I'll give you a link for that in the video description, and if you use this you'll see the hard drive temperatures right down at the bottom of the screen. Studies tend to indicate that hard drives run optimally at a temperature between about 25 and 45 degrees Celsius. And certainly when the drive gets into the 50s, let alone the mid-50s for a sustained period, it is far more likely to fail. So, what do you do to keep your hard drive cool? Well, in a laptop, one of the key things is not to block any ventilation holes, not to block any ventilation vents. And particularly this means do not use a laptop on a cushion or a duvet or any other form of insulator which will cause the computer to retain heat. In a desktop PC, suitable ventilation is also important, and it is possible to fit hard drives with their own coolers with fans on top. And some years ago, if you're wondering what this is, you could actually fit heat pipes onto a hard drive. This is actually a Zalman product, sadly not made anymore. Great product. You had on the side of the drive these great big chunks of blue aluminium on each side, and then you've got heat pipes on the top, and that just mounts in your bay, and it gives you fantastic cooling on the drive. As I say, you can't buy those anymore. I'm teasing you with a great product, isn't still made, but maybe Mr. Zalman will watch this video and go, oh yes, we remember making those. Those were great for cooling down hard drives. Maybe we'll put them back on the market. A final point worth noting here is not about the failure of a hard drive itself, but about the potential loss of data on a drive over a long period of time. Now, this is due to the fact that data written to any form of magnetic media, whether it's a tape or a disk or a hard drive, any form of magnetic media will have data fade across time because the magnetic signals stored in the magnetic media will slowly dissipate. And so to get around that, the only thing you can do is to rewrite the data on a regular basis. So if you're storing a lot of data on drives like this for archival purposes, you should really get them out every few years and rewrite the data. Either blank off a disk and make another copy from where it came from in the first place, or copy it to other parts of the drive or something like that to make sure the data signal actually stored on the drive is refreshed. The other thing you can do is to use a utility to do that for you. You would guess those would exist. You could, for example, use something called Disk Fresh, and I'll give you a link to Disk Fresh in the video description. Now, Disk Fresh suggests you run it 4 times a year. I think that is excessive. I think every sort of 2 or 3 years is absolutely fine, but certainly you shouldn't sort of store data on a hard drive, put one of these in a cupboard somewhere, put it in your attic and expect to come back to it in 10 years or 20 years, the data will be there. The data won't. Data fade is a real issue, and therefore you should think about the fact if you've got hard drives in long-term storage, you should be getting them out, rewriting the data on a fairly regular basis. Back in the late 1990s and into the noughties, I was responsible for the purchase of all the PCs used in my university department. We had about 300 or 400 PCs in use in staff offices and student labs, and we therefore purchased PCs in very large quantities. And I mention this because at the time, hardware failed a lot. And if you'd asked me what is hard drive life expectancy 10 or 15 years ago, I'd have given you a very simple answer. I'd have said hard drives last about 3 to 4 years, because the vast majority of hard drives in our facilities died in 3 or 4 years. Now today, things have changed. Hard drives last a lot longer. There have been studies done looking at failure of hard drives in data centers, and they typically report annual failure rates of less than 5%. And so in theory these days, hard drives could be lasting up to 20 years. Now in practice that's not the case, because data centers will take hard drives out of use to replace with higher capacity models before they fail. But certainly the idea of a hard drive lasting for well over 10 years is perfectly reasonable, maybe even 20 years in some cases. And it should be the case that data will survive on the drive for that period, providing it's refreshed on a regular basis. So there we are, that's what I can tell you about hard drive life expectancy. If you enjoyed this video, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.